morning all. I am Praveena, Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today, in this session, we discussed about the Charpits method. This is related to the partial order differential equations. Partial differential equations. Okay. In that partial differential equations also two types are there. First one is linear partial differential equations and the second one is non-linear partial differential equations. But the Charpits method is related to non-linear partial differential equations. In the previous session, we discussed in the non-linear partial differential equation basic standard forms. Okay, but here we discussed Charpits method is the general form of the non-linear partial differential equations. We discussed that this is a general method for solving equations with two independent variables. Since the solution by this method is generally more complicated, this method is applied to solve equations which cannot be reduced to any one of the standard forms. Okay, this is the general method for solving equations with two independent variables. Already I discussed this is related to non-linear partial differential equation. What is non-linear? How we can here involve two independent variables. Okay, non-linear means order is 1, order is equal to 1 and degree is more than of 1. Okay, order is 1, degree is more than of 1. For that type of equation is called as partial differential equation. And what about the linear differential equation? Linear differential equation means order and degree both are same. Order and degree is both are same. For that type of equation is called linear partial differential equation. Already we discussed in the previous sessions linear partial differential equations Lagrange's method. But in this session we discussed non-linear partial differential equation, that is Charpits method. Okay, when we are using this, since this method is applied to solve equations which cannot be reduced to any one of the standard forms. Okay, this method is applied to solve equations which cannot be reduced to any one of the standard forms. Okay, then I'll discussing about the Charpits method working rule now. Okay, working rule: transfer all terms of the given equation to LHS and denote the entire expression by F. Okay, transfer all terms of the equation to LHS and denote the entire expression by F. And next step, write down the Charpits auxiliary equation. This is the major part of the problem. Okay, auxiliary equation is more important for the Charpits method. What is the form of the Charpits method auxiliary equation? dP by dou F by dou X plus P into dou F by dou Z. That is equal to dQ by dou F by dou Y plus Q into dou F by dou Z. That is equal to dZ by minus P into dou F by dou P minus Q into dou F by dou Q. That is equal to dx by minus dou F by dou P. That is equal to dy by minus dou F by dou Q. That is equal to what? dF by 0. That is not compulsory. Here the auxiliary equation means only 5 terms, that is dP by dou F by dou X plus P into dou F by dou Z, and dQ this and dZ and dx and dy. In the dP, first from the first step we got function in terms of F. For that we got dou F by dou X and dou F by dou Y and dou F by dou Z, and next dou F by dou P and dou F by dou Q. Substitute each and every value in that auxiliary equation. From that auxiliary equation only we got the general solution of the Charpits method. What is the general solution for that? Okay, from that auxiliary equation we got P and Q values. P and Q values. Then substitute these all values in the general solution. What is the general solution formula here? That is dz is equal to pdx plus qdy form. This is the general solution. And after that, from the auxiliary equation we got P and Q values. Here we can substitute the two values and integrating on both sides. Integrating on both sides. Then we got z is equal to, okay, z is equal to px plus qy form. Depends on the question, okay. Integrating on both sides, we got z in terms of general solution in terms of z. That is the concept of the Charpits method. Okay, now I'll go through the first question for the Charpits method. That is, find a complete integral of q is equal to 3p square. What's the first question? This is q is equal to 3p square. By using the above steps for the Charpits method, let us assume the given question as f. Write it in the form of f. That is, here the given equation as f of xyz p comma q is equal to, that is 3p square minus q is equal to 0. Let us assume that as the first equation. Okay, from the given question, I'll assign that as in terms of f, that is equal to 3p square minus q is equal to 0. Okay, and next write down the Charpits equation, that is dp by. Okay, before writing the Charpits equation, first differentiate the given function with respect to x, y, z and with respect to p and q. That is dou f by dou x. Dou f by dou x, that is dou by dou x of 3p square minus q. Okay, that is what? With respect to x, that is 0. Okay, next with respect to y, dou f by dou y. With respect to y is what? That is dou by dou y of 3p square minus q. That is also 0. And next with respect to z. Okay. Next with respect to z. What about dou f by dou z? That is dou z means here 3. Again the function is dou by dou z of 3p square minus q. There is no z term, that's why this is also 0. This is with respect to x differentiation, y differentiation and z differentiation. After that, I'll differentiate with respect to p. That is dou by dou p of 3p square minus q. With respect to p, what is the differentiation for that? That is 6p. Right? And next, with respect to q, dou by dou q of 3p square minus q, that is equal to what? Minus 1. Okay, these are the differentiation with respect to f, differentiation with respect to x, y, z and p and q. Okay, then substitute each and every point in the auxiliary equation. What is the auxiliary equation here? dp by dou f by dou x plus p into dou f by dou z. That is equal to here dq by dou f by dou y plus q into dou f by dou z. That is equal to dz by minus p into dou f by dou p minus q into dou f by dou q. That is equal to dx by minus dou f by dou p is equal to dy by minus dou f by dou q. This is equal to, this is not compulsory. Okay, now we substitute each and every value in the auxiliary equation. That is dp by dou f by dou x. What is the value of dou f by dou x? That is 0. Plus p into, what about dou f by dou z? That is also 0. That is equal to what? dq by, what about dou f by dou y? That is 0 plus q into dou f by dou z also 0. That is equal to dz by minus p into, with respect to p differentiation function, that is 6p. That is minus p into 6p. Minus p into 6p means what? Minus 6p square. Minus q into dou f by dou q, that is minus 1. That is minus q into minus 1 is, that is plus q. That is equal to dx by, what is minus dou f by dou p? That is 6p. That is minus 6p. That is equal to dy by 1. What is 1 here? 1 means what? Minus 1. Minus dou f by dou q is equal to how much? Minus 1. Then substitute here, that is equal to dy by 1. Okay. From that auxiliary equation we got like this, that is dp by 0 plus p into 0 is equal to dq by 0 plus q into 0, and that is equal to dz and next dx and dy. Let us assume that as second equation. Okay, that is r1.111. Okay, taking the first fractions from that auxiliary equations, I'll take first two fractions. Okay, why? Because where we got the easily answer from PRQ from the auxiliary equation, then we can take that 2. Okay, here from DP and DQ only, easily I got either PRQ. Okay, now I'll take first two terms from the, okay, auxiliary equation. That is what are the first two terms from the auxiliary equation? DP by 0. Here I'll write that as DP by 0, that is equal to dq by 0 and dz by minus 6p square plus q and dx by minus 6p, and that is equal to dy by 1. From that auxiliary equation, I'll take first two terms. Why? Because from the two terms only, easily I got p. Okay, that's why here, okay, p, that is from the two terms, dp is equal to what? 0. So that p is equal to how much? After the integration, that is p is equal to a. Okay, from that first two terms, easily I got dp, p is equal to a. Let us take that as the third equation. That as third equation or 1.112. Okay, substitute that p value in the given question. Okay, if you got p value, from that you got q value. Okay, now from that p, substitute that p value in the given question. What is the given question here? Q f of x comma y comma z, p comma q is equal to 3p square minus q. Okay, f of x y z comma p comma q is equal to what? 3p square minus q. From that auxiliary equation already we got p is equal to a. Then substitute here. We got q is equal to what? This is equating with 0 and that q is equal to what? 3a square. Q is equal to 3a square. From that auxiliary equation, now we got p value. After substituting p value in the above function, that is the given question, we got q value. Okay, these are p and q. Putting these values of p and q in, dz is equal to, what is the general solution formula? This is dz is equal to pdx plus qdy. Putting these values of p and q in, dz is equal to pdx plus qdy. We get dz is equal to what? Substitute p. What is p? A into dx. Plus what is q? 3a square into dy. Integration on both sides. Here dz is equal to a into dx plus 3a square into dy. Integrating on both sides, that is a dx plus 3a square into integration of dy. That is a dx means a is I'll take outside, dx integration as x plus 3a square into integration of dy as y plus the constant as b. Therefore, general solution for the, okay, Charpits method, this is the complete integral or general solution, that is z is equal to ax plus 3a square y plus b. Okay, this is the first question answer. Once again, I'll repeat how to solve the Charpits method. Charpits method means, for the first step is, for the given question, let us assume in terms of f. After that, take auxiliary equation. From that auxiliary equation, okay, we got either p value and q value. Okay, if you got p value means substitute that p value in the given question, we got q value. If you got from the auxiliary equation q means substitute that q value in the given question, then we get p value. Okay, then you can substitute that p and q values in the dz is equal to pdx plus qdy. After that, integrate, we got the general solution or complete integral, that is z is equal to ax, okay, ax plus 3a square by plus b. That's the concept of the, okay, Charpits method. Now I'll go through the second question from the Charpits method. That is, using Charpits method to find the complete integral of z square is equal to pqxy. Okay, z square is equal to pqxy. Let us take the given question as in terms of f. that is f of xyz pq is equal to pqxy minus z square is equal to 0. Okay, let us assume that as the first equation. Okay, that as the first equation. First, I'll differentiate with respect to x. What about the differentiation with respect to x? Dou f by dou x is equal to, that is, make a dou by dou x of pqxy minus z square. The differentiation is what here? pqy. Okay, with respect to xz as 0 and here pqy as constant, that x differentiation as 1. Therefore, dou f by dou x is equal to pqy. And next, differentiation with respect to y, okay, that is dou f by dou y is equal to what? That is, simply we got that is pqx. That is pqx. And next, with respect to z, okay, for the differentiation of that is 2z, okay, minus 2z. Next, dou f by dou p. Okay, this is minus 2z. And what about dou f by dou p? That is with respect to p means that is qxy. With respect to p means qxy. And next, with respect to q. With respect to q as pxy. Okay, that is differentiation with respect to x, y, z, p and q. Now substitute each and every value in the auxiliary equation. What is the form of the auxiliary equation here? dp by dou f by dou x plus p into dou f by dou z is equal to, this is dq by dou f by dou y plus q into dou f by dou z, that is equal to dz by minus p into dou f by dou p minus q into dou f by dou q, that is equal to what? dx by minus dou f by dou p, that is equal to dy by minus dou f by dou q. Now substitute each and everything here, that is dx, okay, or write it as simply or dx, dy, dz, dp, dq, or directly substitute here only dp by, okay. But here I am taking first dx by, what is minus dou f by dou p, that is qxy, that is dx by minus qxy, and dy by, okay, dy by, what is dou f by dou q, pxy minus pxy. And what about dz by minus p into dou f by dou p. What is dou f by dou p here? Dou p as qxy, that is here minus pqxy minus of q into dou f by dou q as pqxy, that is pqxy, that is equal to dp by, okay, dp means what? Dou f by dou x plus p into dou f by dou z, that is p into, what is dou f by dou x here? Dou f by dou x is directly pqy plus p into dou f by dou z, that is what? That is equal to p into here minus 2z, that is minus 2zp. Therefore, dp by pqy minus 2zp, that is equal to what? dq by dou f by dou y. What is dou f by dou y here? pqx. Substitute there plus q into dou f by dou z is what? Minus 2z, that is pqx minus 2zq. Okay, then that is, or write it as simply that as dx by minus qxy is equal to dy by minus pxy, that is equal to dz by minus 2p. Add both the values here, these two are same, that is dz by minus 2p qxy, that is equal to simply dp by, here what is common term in both the terms? That is p. I'll take outside and the remaining as qfy minus 2z, that is equal to dq by, here what is common in both the terms? Q is common, then q into px minus 2z, dq by q into px minus 2z. From that, let us take from that auxiliary equation, I'll take, okay, is there any possibility to take directly from any two terms from the auxiliary equation? Okay, If you are taking any two terms of the auxiliary equation, we got either P or Q. Here there is no possibility. That's why I'll take here, okay. That's why I'll take here dP by P, okay. dP by P minus dQ by Q form. That is equal to dy by y minus dx by x form. Okay, dP by P minus dQ by Q is equal to dy by y minus dx by x form. That is dP by, okay, P into, once you observe here, what is P? P into Qy minus 2z. That means I'll dividing with P. Okay, that means here P cancel. We got Qy minus 2z minus Px plus 2z. Okay, here P cancel. After subtracting with that, here I'm multiplying with P and Q. Okay, here I'm dividing with P and Q. From that, here we got Qy, okay, minus 2z minus Px plus 2z. That is equal to here dy by y minus dx by x. That means what? Here differentiation of with respect to y is dividing with y and x is differentiate with respect to x, that will be dividing with x. Subtracting both. Here from the auxiliary equation, what is dy? dy as minus pxy. Okay, that is dy by y. Here minus pxy by y. Here y cancel here. We got qy only. Okay, next one dx by x, and that is if you are taking that with different dividing with x, here we got px. Therefore qy minus px. From that, from the dp by p minus, this is minus dq by q by, here once you see 2z and minus 2z cancel. dP by P minus dQ by Q by Qy minus 2z minus Px plus 2z. Here plus 2z and minus 2z cancel. From that RHS side, dy by y minus dx by x divided by Qy minus Px. There is no, okay, common terms here. Directly here Qy minus Px. From that, here I'll write that as simply, once you observe, both side denominators are cancelled. Qy minus px are cancelled. Therefore, dp by p minus dq by q is equal to dy by y minus dx by x. Okay, dy by y minus dx by x. From that, here I'll take p and x terms in LHS side, y and q are in RHS side. Okay, from that integrating both sides, that is integral of, here integral of dp by dp plus dx by x, that is equal to integral of dq by q and plus dy by y. Okay, this is integration on both sides. From dp by p, 1 by p integration as log p and 1 by x integration is log x. That is equal to, okay, dq by q. 1 by q integration is log q and 1 by y with respect to y integration as log y. Therefore, log p plus log x is equal to log y plus log u, okay, log q. Okay, these are all in logarithmic terms. That's why I'll take the constant also in terms of logarithmic. That is plus log a square. Plus log a square. Okay, next step here, which is in the form of, after the integration LHS side, as log m plus log n formula. That is log m plus log n formula, log mn. That means log p plus log x is px. Is equal to, this is log m plus n plus r formula, that is log of y q a square. Okay, log px is equal to log y q a square. Both sides logarithmic cancel. From that, px is equal to what? Px is equal to qy a square. From that, once you observe, both sides logarithmic cancel. From that, we got P is equal to what? Qy a square by x. P is equal to Qy into a square by x. Okay, from the auxiliary equation, we got P value. Now we can substitute that P value in the given question. What is the given question here? That is PQXY minus Z square. Here the given question, f of x comma y comma z comma pq equal to pqxy minus z square is equal to 0. Okay. Then substitute here p. What is p here? Qy a square by x minus qy a square by x minus z square is equal to 0 into here xy. Okay. P as Qy a square by x, already here xy, that is xy minus z square is equal to 0. Here x cancel, from that Qy, okay, Q a square, and here one more Q also there, that is Q into, that is Q square, y square, and a square minus z square is equal to 0. Once again, I'll write clearly here. P into Q as Qy a square by x into xy minus z square is equal to 0. From that, here x cancel. That is q square. This is q1 not p. Q square y square a square the x cancel, that is equal to z square. From that, what is q? Q is equal to, I'll write simply z square by a square y square, that is q square is equal to. From that, what is q? Okay, that is z by ay. This is q is equal to z by ay. Okay, here in place of p, I am substituting qy a square by x. This is q only. Okay. From that, after the simplification, we got q is equal to z by ay. From the auxiliary equation, we got p is equal to what? Za by x. How we got p is equal to za by x? Already we know that q is in terms of z by ay. I'm substituting that is in p is equal to qy a square by x. Once you observe here, what is q? Q is equal to what? Z by ay into y into a square by x. Here y cancel and 1 a cancel, that is za by x. Therefore p is equal to what? Za by x. Okay. Next step. Now we got p and q values. Then substitute the two are in the formula of dz is equal to p dx plus q dy. That is dz is equal to, here what is p? Za by x into dx plus what is q? Z by ay into dy. Okay, then here what is common in RHS side? That is z as common, that is dz is equal to z into a by x into dx plus 1 by ay into dy. From that, dz by z is equal to a by x into dx plus 1 by ay into dy. Now integrating on both sides, dz by z means that is logarithmic of z. That is equal to integration with respect to x, a into log x plus here 1 by I'll take outside with respect to y integration, that as log y. Okay, I'm taking the constant also in terms of logarithmic, that is log b. Therefore log z is equal to log z is equal to what? A into log x plus 1 by a into log y plus log b. That is, I'll write simply here, which is in the form of a into log n into log m. That is log m power n. That is a plus log y power 1 by a plus log b. From that, after the writing the logarithmic formula here, which is in the form of log a plus log b plus log c. That is log of abc, x power a, y power 1 by a into b. That is equal to log z. Therefore, both sides logarithmic cancel. From that, z is equal to what? X power a into y power 1 by b into b. Therefore, the complete integral or general solution for the second question, z is equal to b into x power a into y power 1 by a. That's the second question answer. Again, I'll go through the next question here. That is the third one. Using Charpits method to find the complete integral of z square of p square z square plus q square is equal to 1. Okay. Then I'll assume the given question f in terms of f, that as f of x comma y comma z comma p comma q is equal to z square of p square z square plus q square minus 1 is equal to 0. Let us assume that as the first equation. For that, differentiate with respect to x. Differentiate with respect to x, that as 0. And differentiate with respect to y, that as 0. And differentiate with respect to z. Okay, how to differentiate with respect to z? That is dou f by dou z is equal to, I'll take z square inside the brackets, that is p square z power 4 plus q square z square minus 1. Okay, differentiate now with respect to z. That is p square into z power 4, differentiation as 4 into z cube plus q square into 2z, and 1 differentiation as 0. Therefore, here with respect to z, 4p square z cube plus 2q square z, that is dou f by dou z. Next, differentiation with respect to p. Differentiation with respect to p, that as, okay, then 2p, p square differentiation as 2p into z power 4. That is 2p z power 4. And what about with respect to q? That as, okay, that is 2q into z square. Okay, from directly I'm writing here, q square differentiation is 2q. Already here z square, that is 2q z square. Therefore, dou f by dou q is equal to what? 2q z square. Therefore, now substitute each and every value in the Charpits auxiliary equation. What is the form of the auxiliary equation? dp by dou f by dou x plus p into dou f by dou z. That is equal to dq by dou f by dou y plus q into dou f by dou z. That is equal to dz by minus p into dou f by dou p minus q into dou f by dou q. That is equal to dx by minus dou f by dou p, that equal to dy by minus dou f by dou q. Now substitute each and every point here. This is minus. Now substitute dp by, okay. What is the first equation? Dou f by dou x plus p into dou f by dou z. What is dou f by dou x? 0. Plus p into what is dou f by dou z? 4p square z cube plus 2q square z. First term as 0. Okay, plus p into dou f by dou z this. And dq by dou f by dou y also 0. Okay, that is 0 plus q into dou f by dou z, that is 4p square z cube plus 2q square z, that is equal to dz by, what is the form of dz? Minus p into dou f by dou p minus q into dou f by dou q. Substitute each and every value here. We got dz by minus 2p square z power 4 minus 2q square into z square. That is equal to what is dx? Dx by minus dou f by dou p. What is dou f by dou p here? 2p z power 4. Here in the formula minus, that is minus 2p z power 4. df by minus dou f by dou q. Dou f by dou q as 2q z square minus. Okay, now from that auxiliary equations, now I'll assume first two fractions. From that maybe possibility from the first two fractions only, I got either p or q. Okay, na? That's why I'll take here first two fractions from the auxiliary equation. What are the two here? dp by p into 4p square z cube plus 2q square z is equal to dq by q into 4p square z cube plus 2q square z. Okay, from that observe here both sides, these two are cancelled. Okay, that is equal to dp by p and is equal to dq by q. Now integrating on both sides. That is integral of dp by p is equal to integral of dq by q. That is 1 by p integration is log p and integration of q as log q, and I'll take the constant in LHS side, that is log a. That means log p plus log a is equal to log q. Then from log m plus log n formula for the LHS side, that is log mn. That is log ap is equal to log q. Both sides logarithmic cancel. We got q is equal to ap. Here we got q is equal to ap. Okay, from that if you are taking the first two terms from the auxiliary equation, here we got q is equal to ap form. Okay, now substitute q is in, okay, first equation. What is the first equation? Given question form. Okay, what is the given question here? z square into p square z square, okay, plus q square is minus 1 is equal to 0. Already from the auxiliary equations, q is equal to what? Q is equal to ap. Substitute here, that is z square into p square z square plus a square p square minus 1 is equal to 0. Okay, from that z square into p square z square, here what is common from these two terms? Okay, here p square is common. Okay, I'll take p square common, that is z square plus a square. This is equal to 1. Okay, from that what is p square? P square is equal to 1 by z square into a square plus z square. Okay, from that what is p? P is equal to 1 by z into under root a square plus z square. Okay, therefore from here what is p? P is equal to 1 by z into under root a square plus z square. Okay, then here from p we got q also. What is q? Q is equal to a by z into root of a square plus z square. Okay, why? Because already from the auxiliary equation we know that what is q? Q is equal to ap. Then substitute p from there. We got q is also in terms of a by z into root of a square plus z square. Now the general solution of that, or complete integral, dz is equal to, what is the form of that? P dx plus q dy form. Now substitute here p as dx by ps z into root a square plus z square plus dy by here a, that is q as a by z into root a square plus z square. Then simply I'll write, that is here the LCM is z root of a square minus z square. I'll take that as in LHS side, that is z root of a square plus z square into dz is equal to dx plus a into dy. Integrating on both sides. Now integrating on both sides, integral of z into root a square plus z square into dz is equal to integration of dx plus a into integration of dy. Okay, here the LHS side integration is very simple. Integral dx is equal to x and integral dy as y. A into y. plus constant as b. What about LHS side? How you got integral t square dt? For that, integral of LHS side, integral z of root a square plus z square dz integration. For our convenience, I'll reduce the equation as one variable, that is a square plus z square is equal to t square. Okay, now differentiate with respect to the t, that is a square plus z square is equal to t square. Differentiation as here 2z dz is equal to 2t dt. Okay, that is dz by, with respect to t differentiation, that is 2z dz is equal to 2 into t dt. Here 2 cancel, from that z dz is equal to what? T into dt. Now substitute these all terms here. Then integral of z into dz is equal to what? I'll write this step here. Z into dz as t into dt. Root a square plus z square means here from the first step, that is t. That is equal to root dx plus a into root dy. T into t means what? Integral of t square dt. That is equal to integral of dx plus a into integral dy. Now integrate both sides, that is t square integration as t cube by 3. Already we discussed RHS side. Directly we got x plus ay plus b form. Then from that here, but what is t? What is our assumption from that? T is equal to what? A square plus z square root of a square plus z square. Just substitute there, that is a square plus z square into whole power 3 by 2, and here 3 I'll take in RHS side, that is 3 into x plus ay plus b form. Okay, now from that a square plus z square whole cube is equal to 9 into x plus ay, that means squaring on both sides. If you are squaring on both sides, directly we got a square plus z square whole cube is equal to 9 into x plus ay plus b whole square. Okay, this is the required complete solution for the third question. Okay, these are the questions from the Charpits method. It is very important method. Okay, next class we will discuss some other related topics. Okay, thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.